Fire-rated expanding foam sealant is a product commonly used in electrical applications to seal around conduits, cables, and other openings where wires pass through. It's designed to prevent liquid transmission and, importantly, provide fire resistance. This type of sealant expands to fill the void around the wires within the conduit knockout, creating a barrier that is both fire-resistant and watertight. When dealing with a conduit knockout that has a plastic bushing and wires running through it, and where there's a concern about water potentially dripping down onto the wires and entering the cabinet, applying fire-rated expanding foam sealant is a suitable solution. The primary function is to seal the opening effectively, preventing water ingress and mitigating the risk of electrical hazards that could arise from moisture exposure. Furthermore, the fire-resistant properties of the sealant add an extra layer of safety by helping to contain or slow the spread of fire in the event of an electrical fault. Applying this sealant involves several steps to ensure its effectiveness. Firstly, preparation is key. Before applying the sealant, make sure the area around the conduit knockout and the wires is clean and dry. Remove any dirt, dust, or debris that could interfere with the sealant's adhesion. Secondly, shake the can of expanding foam sealant thoroughly. This ensures that the components are properly mixed, which is essential for the foam to expand and cure correctly. Thirdly, attach the nozzle or applicator tube that comes with the sealant can. This will allow you to direct the foam precisely into the opening around the wires and the conduit knockout. Fourthly, apply the sealant sparingly. Remember that the foam will expand, so it's better to start with a small amount and add more if needed. Overfilling the opening can lead to excess foam that's difficult to clean up. Fifthly, direct the nozzle into the gap between the wires and the conduit knockout and begin applying the foam sealant. Move the nozzle slowly and steadily to ensure even coverage around the entire opening. Sixthly, allow the foam to expand and cure according to the manufacturer's instructions. This usually takes a few hours depending on the specific product and environmental conditions. Avoid disturbing the foam while it's curing. Seventhly, once the foam is fully cured, trim any excess foam that protrudes from the opening. Use a sharp knife or utility knife to carefully cut away the excess, leaving a clean and neat seal. Eighthly, inspect the seal to ensure that it's complete and there are no gaps or voids. If you find any imperfections, apply additional sealant as needed to fill them in. Ninthly, consider the type of wires. Ensure that the sealant being used is compatible with the wire insulation. Some sealants might degrade certain types of insulation over time. Tenthly, always follow the manufacturer's safety guidelines. These guidelines will provide specific safety measures, such as wearing gloves and eye protection, and ensuring adequate ventilation during application. Fire-rated expanding foam sealants are tested and certified to meet specific fire resistance standards. These standards, such as those set by Underwriters Laboratories, or similar organizations, ensure that the sealant can withstand exposure to fire for a specified period, helping to prevent the spread of flames and smoke. The fire rating is typically expressed in terms of IRs, such as 1 IR fire rated or 2 IR fire rated. When selecting a fire-rated expanding foam sealant, it's important to choose one that meets the applicable building codes and regulations for the specific application. Building codes often specify the minimum fire resistance requirements for various types of construction and electrical systems. Using a sealant that doesn't meet these requirements could result in code violations and compromise safety. A key aspect is the expansion rate and density. Different foam sealants have different expansion rates, which determine how much they expand after application. It's important to choose a sealant with an appropriate expansion rate for the size of the gap or opening you're sealing. Too much expansion can create excessive pressure and distort the surrounding materials, while too little expansion may not provide a complete seal. The density of the foam also affects its sealing and insulating properties. Higher density foams tend to be more durable and provide better resistance to water and air infiltration. The properties of adhesion and flexibility are critical as well. The sealant must adhere properly to the surfaces it's applied to, including the conduit, wires, and surrounding materials. Poor adhesion can lead to gaps and leaks, compromising the seal's effectiveness. Flexibility is also important, especially in applications where there may be movement or vibration. A flexible sealant can accommodate these movements without cracking or losing its seal. Regarding water resistance and fire resistance, look for sealants that are specifically designed to be both water resistant and fire resistant. Water resistant sealants prevent moisture from entering the conduit or enclosure, protecting the wires and electrical components from corrosion and damage. Fire resistant sealants help to contain or slow the spread of fire, providing valuable time for evacuation and fire suppression. It's essential to verify the fire resistance rating of the sealant and ensure that it meets the requirements of the application. Furthermore, consider the environmental factors when selecting a sealant. Some sealants are designed for indoor use only, while others are suitable for outdoor applications. Outdoor sealants must be able to withstand exposure to sunlight, rain, temperature extremes, and other environmental factors. It's also important to consider the sealant's resistance to chemicals and solvents, especially in industrial or commercial environments where exposure to these substances is possible. Consider the application method. Expanding foam sealants are typically applied using an aerosol can with a nozzle or applicator tube. The application method can affect the ease and precision of applying the sealant. Some sealants come with adjustable nozzles that allow you to control the flow rate and pattern of the foam. It's important to choose a sealant with an application method that's suitable for the specific application and your skill level. When selecting a fire-rated expanding foam sealant, it's essential to consider the specific requirements of the application, including the size and shape of the opening, the type of materials being sealed, and the environmental conditions. It's also important to consult with a qualified electrician or building inspector to ensure that the sealant meets all applicable codes and regulations. The long-term performance of a sealant is a critical factor to consider, especially in electrical applications where reliability and safety are paramount. Factors such as aging, weathering, and chemical exposure can affect the sealant's properties and performance over time. Look for sealants that have been tested and proven to maintain their sealing and fire-resistant properties for an extended period. Some manufacturers offer warranties or guarantees on their sealants, providing added assurance of their long-term performance. Proper installation is crucial for ensuring the effectiveness and longevity of a fire-rated expanding foam sealant. Following the manufacturer's instructions carefully is essential for achieving a proper seal and preventing premature failure. In addition to cleaning and preparing the surfaces, it's important to apply the sealant in the correct thickness and avoid overfilling or underfilling the opening. Using the correct application technique and tools can also help to ensure a consistent and reliable seal. Regular inspection and maintenance can help to identify and address any potential problems with the sealant before they become serious. Check the sealant periodically for cracks, gaps, or other signs of damage. If any problems are detected, repair or replace the sealant as needed to maintain its effectiveness. Keeping the sealant clean and free of debris can also help to prolong its life. Consider the cost. Fire-rated expanding foam sealants vary in price depending on their quality, features, and brand. While it's important to choose a sealant that meets your performance requirements, it's also important to consider your budget. Compare the prices of different sealants and choose one that offers the best value for your money. In some cases, it may be worth paying a little more for a higher quality sealant that will provide better long-term performance and reliability. While using a fire-rated expanding foam sealant can effectively seal conduit openings and prevent water from entering, it's important to be aware of potential limitations and considerations. These include the sealant's compatibility with different types of wires and cables. Some sealants may not be compatible with certain types of insulation or jacketing materials, which could lead to degradation or damage over time. It's important to check the sealant's compatibility with the specific wires and cables being used in the application. The sealant's ability to withstand movement and vibration is also a factor to consider, especially in applications where the conduit or enclosure is subject to movement or vibration. Some sealants may crack or lose their seal over time if they are not flexible enough to accommodate these movements. It's important to choose a sealant that's designed to withstand the specific conditions of the application. The sealant's resistance to chemicals and solvents can also be a concern in certain environments. Some sealants may be affected by exposure to chemicals or solvents, which could lead to degradation or failure. It's important to check the sealant's resistance to the specific chemicals and solvents that may be present in the application environment. Proper surface preparation is essential for ensuring the sealant's adhesion and performance. The surfaces being sealed must be clean, dry, and free of any contaminants that could interfere with the sealant's bond. It's also important to follow the manufacturer's instructions for surface preparation, such as using a primer or surface activator. The sealant's expansion rate and curing time can also affect its application and performance. Some sealants expand rapidly and cure quickly, while others expand more slowly and take longer to cure. It's important to choose a sealant with an expansion rate and curing time that's appropriate for the specific application. Proper ventilation is important when applying expanding foam sealants, as they can release fumes that may be harmful if inhaled. It's important to work in a well-ventilated area and wear appropriate respiratory protection, such as a respirator or dust mask. Regarding waste disposal, follow local regulations when disposing of used sealant containers and excess sealant material. Some sealants may be considered hazardous waste and require special disposal procedures. Fire-rated expanding foam sealant is a versatile and effective solution for sealing conduit openings and preventing water from entering, but it's important to consider its potential limitations and choose a sealant that's appropriate for the specific application. Always follow the manufacturer's instructions for installation and safety precautions, and consult with a qualified electrician or building inspector if you have any questions or concerns. A good option is to use a sealant that is UL listed. All formerly Underwriters Laboratories is a globally recognized safety organization that tests and certifies products for safety and performance. A UL listing indicates that the sealant has been tested to meet specific safety standards and requirements. When choosing a fire-rated expanding foam sealant, look for one that's UL listed for the specific application, such as sealing conduit openings. This will provide assurance that the sealant has been tested and meets the necessary safety standards. Also, it's important to understand the different types of conduit fittings. There are various types of conduit fittings available, each designed for specific purposes and applications. These fittings are used to connect conduit sections, terminate conduit runs, and provide access points for wiring. Some common types of conduit fittings include couplings, connectors, elbows, tees, and bushings. Couplings are used to connect two sections of conduit together, providing a continuous raceway for wires. Connectors are used to terminate conduit runs at electrical boxes or equipment enclosures. Elbows are used to change the direction of a conduit run, allowing it to turn corners or navigate around obstacles. Tees are used to create branch circuits, allowing multiple conduit runs to be connected together. Bushings are used to protect wires from abrasion as they enter or exit conduit. It's important to select the appropriate type of conduit fitting for each application to ensure a secure and reliable electrical system. Each type of conduit has its own set of compatible fittings, and using the wrong fitting can compromise the integrity of the raceway. Furthermore, different types of conduit, such as rigid metal conduit or RMC, intermediate metal conduit or INC, electrical metallic tubing or IMT, and flexible metal conduit or FMC, require different types of fittings.